Okay, here we go, 7.2. We're still talking quadrilaterals and other polygons, but 7.2 we're going to specifically be talking about parallelograms. Okay, and we're going to be talking about what makes a parallelogram, and everything in between. So it's all parallelograms, okay? We're going to be starting in GeoGebra again. They like to construct these shapes and then talk about the properties. So we're going to construct a parallelogram. So to do that, what's one thing we know about parallelograms? Well, really the basic thing about a parallelogram is that its opposite sides are parallel. Okay? Well, I'm going to do this. I'm going to construct, I'm going to go in here, I'm going to make a line. Yep, a line. I know I've been doing segments a lot, but I find this one easier to do with a line. Okay? So there is my line. I'm going to make a parallel line to this line, right? Because opposite side is parallel. Now, what am I gonna do? I'm going to delete that really quick. My bad. I want to delete that. Delete. Okay. Delete. Sorry, when I make a parallel line, I want to click one of these points. Okay? Parallel line. There we go. Now, what I want to do is I want to make a line between B and C. Okay, now I need another parallel line to that. So I'm going to click on the line, and then I'm going to click on point A. And that should create this parallelogram. And I'm going to draw a point right where those lines intersect. So right there. Now, I construct my parallelogram. We want to find the angle measure of the parallelogram. So let's find the angle measure of each angle. So we've got to go to measure, angle measure, find the measure of each angle. There's B, there's C, there's D, and then there's A. So what do we notice? Well, let's look at A, 66.6. We know that C is 66.6. So opposite angles, right? If we looked at B, 113.4, D, 113.4, opposite angles are congruent. Opposite angles are congruent. What else do you observe? Well, let's only look at two angles here. Let's look at A and B. 66.6 and 113.4. Let's add those together. Six plus 4, that's 10. 6 plus 3 is 9, plus that 1 is 10. 6 plus 1 is 7, plus that 1 is 8, and then that 1 drops out. Look at that, 180 degrees. Hey, what do we know about 180 degrees? What do we call that? Well, we're going to say those are consecutive angles. But they add up to 180. They are supplementary. Supplementary. Okay, so consecutive angles are supplementary. That's our knowledge about parallelograms. Okay. Then asked to find the side lengths of the parallelogram. What do you notice? So let's measure the side lengths. Let's get rid of our color. Let's just focus on side length. So we're going to go find distance length. We're going to click on 2 points. So BC is 5.2. CD is 7.3. DA is 5.2. And AB is 7.3. So, what do we know? Opposite sides are congruent. Opposite sides are congruent. We got 7, 3, we got 7, 3. We got 5, 2, we have 5, 2. Okay, opposite sides are congruent in a parallelogram. Repeat those parts. That's what they want us to do for D. We really don't have to. We know just based off our parallelogram we created that opposite angles are congruent, consecutive angles are supplementary, and opposite sides are congruent. Here it says constructing a parallelogram. We're going to stick with the one we have. And it says draw the two diagonals of the parallelogram. The two diagonals, okay? The two diagonals of a parallelogram go from one vertice to the opposite vertice. Okay, and then label the intersection point E. Perfect. Then we have to find the segments. Okay, well, let's clean this up a tad. Let's delete these little measurements here. Oh, I did not want to do that. Can I undo? No, why would I? Okay, we'll just start over. We'll just start with the new parallelogram. That's fine. Here, let's find the point here. Let's just put it. Let's make a new parallelogram, huh? Put it here. Now I want a line, a parallel line to here. I'm going to click that line and then point C. I'm going to make another line between B and C, and then I want a parallel line from that line to A. There's our parallelogram. Okay, now what I want to make those diagonals. So I'm going to make a segment from A to C, and a segment from D to B. There's my diagonal. And I have a new point right on my intersection, right there, point E. I'd show label, get rid of that, get rid of that. Okay, there we go, point E. Okay, now it says to find the distance of this one, and this one, and then this one, and this one. Okay, we want to find those little lengths. Find the distance or length, which is, if we scroll down right there. So the distance between A and E is 4.3. Let's find CE. E and C. 4.3. Look at that. How about DE? 4.4 and EB? 4.4. What do we notice? E is the midpoint. Right now, if I moved these lines, okay, let's just take a look there. Notice it doesn't really matter where I move those. E is always the midpoint of the segment. Right? So, what do you observe? The midpoint of the two, sorry, not the midpoint, the intersection. The intersection of the two diagonals is the bisector of each diagonal. Okay? Repeat parts A through C. For parallelograms, we just kind of did that. This part, what are the properties of the parallelograms? We know that opposite sides are congruent, right? So we can say opposite sides and angles are congruent. Okay. Consecutive sides are supplementary. and the intersection of the diagonals is the bisector of the two diagonals. Okay? Now, moving on. We are writing what a parallelogram is. And I'm going to get my book out for us so we can get this right. In my 7.2 textbook, let's see what they say for parallelograms. So the parallelogram is a quadrilateral, wow, that's an I right there, not an A. Quadrilateral with both pairs of opposite sides parallel. That's the book's definition of a parallelogram. Okay, well, let's get into the specifics, more detailed. Down here, parallelogram, opposite sides theorem says that its opposite sides are congruent. Okay, we know that. Its opposite angles are congruent, so that's the opposite angles theorem. The consecutive angles theorem, right? That's what I was saying about supplementary. Here, x plus y equals 180. X plus y equals 180. X plus y is 180. And finally, x plus y is 180, right? So any two angles, any two consecutive angles add up to 180 degrees in a parallelogram. Here, the diagonals theorem says that when M is the intersection of the two diagonals, it is the diagonal's midpoint. Moving on, some extra practice here. Knowing all that information about parallelograms, we can find x and y. We want to find x, we want to find y. So what do we know? Well, we know that this side is congruent to this side. So those are congruent sides. We can set them equal to each other. We can say x plus 18 is equal to 3x minus 2. Okay, if I solve this, I get 20 is equal to 2x. X is equal to 10. Okay, well, that's good. Well, if we know that this side is congruent to this side, we know that 4x is equal to y. We know that x is equal to 10, so this is 40 equals y. Perfect. Number 2. Well, we know that this angle is congruent to this angle, so we know that 49 is equal to 4x minus 37. Okay, if I add 37 to 49, I get 86. Right? No, I didn't do that right. Yeah, I did. 49 plus 37, pull up my code, 86. 86 divided by 4. X is equal to 21.5. Okay? Good? Well, we know that this side and this side is congruent, so if we said 4x minus 3 is equal to y over 5, we know that x is 21.5. We know that this is 86 minus 3. 83 is equal to y over 5 multiplied by 5. 83 times 5, we get y is equal to 415. Perfect. Last one, number 3. Number 3, we know that this is congruent to this. We know that this is congruent to this. So let's start with y this time. We have 5y minus 16 is equal to 3y. Doing the math here, I get 2y is equal to 16 divided by 2. We get y is equal to 8. And then for x, I have 2x plus 10 is equal to 4x minus 2. And do this math, I get 2x is equal to 12, and x is equal to 6. Moving on to some more practice. We're going to go quickly here. Find the measures. Okay, this is a parallelogram. This shape here tells me that it's a parallelogram. Then it says explain your reasoning. Well, PO. Find PO. Number 4, PO. Where's PO? It's this length here. Well, we know that that length is equal to MN, and that's 24. So we're going to say 24. We're going to say opposite sides theorem. Okay, how about OQ? OQ is the same as MO, so that's 14. What's our reason? Scroll up. What's our reason here? What do we talk about? We talk about parallel diagonal theorem. Perfect. Diagonal theorem. Okay, these are all parallelogram something something theorem. So right now, I'm just going to say diagonals. NO, where is NO? Find that for me. NO is 20.7. Oh, they give that to us. Nice. I'm going to say 20.7. It really isn't a theorem. That's just given. Nice. How about PQ? Oh, PQ is equal to NO. Oh, no, it doesn't. Sorry. See, I made a mistake. I made a mistake. That's a Q in the middle. NO is right here. And that's equal to this side, which is 26. Again, that's opposite sides theorem. Now, PQ. PQ is equal to 20.7. That's diagonals. How about PMN, the angle of PMN? We start at P, go up, it's this angle here. Well, we have to do some math here. Okay, because angle N is 68. Okay, this is 68 degrees. Which means this is 68 degrees. Okay? We know that 68 plus 59 plus x is equal to 180. So 68 plus 59 plus x is equal to 180. 68 plus 59 is 127. And then if I subtract 127 from 180, I get 53. So x is equal to 53. So knowing that, 53 plus 59, because that's what I have to do to find this angle, This whole angle is 112, which means this whole angle is 112. Reasoning, I just did all my math work there. I could say opposite angles. Okay? How about NOP? NOP, I'm going to keep all my angles there because that's important to know. NOP is 112. Just found that. OPM is 68. Again, I found that. And NMO. NMO. That's this angle here. What does that equal? Well, here's 59. These are parallel lines, right? So here's going back in the past, cut by a transversal. Hey, you know why that NMO is 59? Because the alternate interior angles. Ha! Way back in the past. Okay, so we're bringing out some old information. That's good. We're connecting the dots. All right, but that is 7.2.